Okay, this is lesson 5-7, Systems of Linear Inequalities. Okay, so it just says that means a set of two or more linear inequalities with the same variable. So this is just like we've been doing on solving systems of equations by graphing, elimination, and substitution, but now we're going to look at with inequalities. It works pretty similar. So the first part, just checking a solution. Tell whether the ordered pair is a solution of the system of linear inequalities. So you just take this point and plug it into both for x and y and see if it comes out true. So like on A, the point 3,5. So that means 5 is y, 3 is x. So 2 times 3 is 6. 6 is not greater than 5, or 5 is not less than, it is less than 6. Sorry, I was reading it backwards. 5 is less than 6, so that one's true. And then you plug them in for the other one too. Plug 5 in for y, 3 in for x. 3 plus 1 is 4. 5 is greater than or equal to 4. So since it is true for both inequalities, then it is a solution. So your answer would be yes. So then on B, we have the point -2, 0, still for the same inequalities. So we have 0 for y and -2 for x. 2 times -2 is -4. 0 is not less than -4. It's greater. So that one doesn't work. And then you still check this one, but your answer is going to be that it is not a solution because it only worked for one inequality, not both of them. Okay, this part's pretty simple so far. So go ahead and try both of these, and then I will go over it with you. Okay, on these examples, we are determining if this point is a solution to this set of equations, or inequalities. So we plug it in. So on this one, I just need the y. So 5 is less than 5. That is not true. Plug it in on the other. 5 is greater than -1 minus 4. -1 minus 4 is -5, and 5 is greater than that. But because that one was not true, that is not a solution to those inequalities. So I guess no, or not a solution. Okay, on number 2, I'm going to plug those in for x and y. So the first one, I have that y is greater than or kind of helps if I actually plug it in like I say. Okay, so 4 is greater than or equal to 3 times 1 plus 1. 3 times 1 is 3, plus 1 is 4. 4 is greater than or equal to 4. And then my other one, 4 is greater than, almost said 3, 1 minus 1, which is 0, and 4 is greater than that. So since it's true for both, yes, this is a solution to those inequalities. Okay, so now we're going to look at graphing a system of linear inequalities, just like we did with equations, but now it's going to look a little more complicated because with inequalities, we have all of our shading. Okay, so this first example, it just says graph this system of inequalities. So we have y is less than or equal to 3, and y is greater than x plus 2. So we just graph those as if it were equal signs. Don't forget whether it's a dotted or a solid line. This one has the or equal to sign, so it's a solid line. This one is just greater than, so it's a dotted line. So for y is less than or equal to 3, that means there is no x. So I go to 3 on the y-axis, and since there's no x, there's no slope. So it never goes up and down from that point, so it just goes straight across. Solid line, y is less than or equal to 3. So if this is 3, the only way to be less than that is to get smaller. So they've shaded all of that blue. What's probably going to be easiest for us, since we're just using pencil, I would just loosely shade it, kind of just zigzag lines. Okay, so then our next equation, y is greater than or x plus 2. So we go to 2 on the y-axis, slope is 1, up 1 over 1, and it's a dotted line, and y is greater than that, so it's getting bigger. So then I would take your shading and do it zigzags the other way. So then your kind of your answer or the solution is the part where they're both shaded, where it's got two directions, and you can go back once you're done and kind of make that part a little darker, if that makes sense. So we have this little triangle right here is our solution, all of that. Okay. It does say you can find the intersection of the half plane. So one solution, all that means is you can pick any number in that part and it's a solution, and you can use that to check. So they said -3, 1. Doesn't have to be -3, 1. That's just what they chose. So 1, 2, -3, 1. They chose a point right here. because it's somewhere in that shaded region, and you can plug it in for x and y to make sure it's a solution of both. That'll just help you verify that you shaded correctly. Okay, so another example. Example 3. Graph the system of linear inequalities. So again, we have two inequalities. This time, neither of them are solved for y yet. So we're first going to have to rearrange them before we can graph. So the first one, 2x plus y is less than -1. I just have to subtract 2x to the other side. So I get y is less than, I'm going to put my 2x first, so -2x minus 1. There's our first one. So we go to -1, and then my slope is -2, so down 2/1. And it's a dotted line, and y is less than that. So we're shading over here. Excuse me. So then our other equation, I have to subtract 2x again on this one. So I get y is greater than -2x plus 3. So we go to +3, put a point, my slope is -2, so down 2/1. Again, it is a dotted line, not solid, and y is greater than that. Okay, so what I want to talk about, just because they're parallel, you still have to pay attention, because what if it had been in between? They could have had that as part of a solution. But since they're parallel and the planes do not intersect, this answer would be no solution. And we know that they're parallel because the slopes are the exact same. Okay, so let's look at, I'll move it up to the top. I'm just going to have you do 3 and 5. We won't worry about 4. So try 3 and 5. You're graphing this system of linear equalities, and then I will go over it with you. Okay, on these two, we are graphing the set of inequalities. So on 3, this one is already set up in the y equals form, even though it's an inequality, so I'm going to go ahead and graph it. So I go to 4 on my y-axis, and I put a point. My slope is -1, so I go down 1/1. I'm going to go ahead and do several points. And it's greater than or equal to, so it is a solid line. I almost forgot to check that. Okay, so this one I'm going to solve for y. So I'm going to go ahead and subtract x to the other side. And I get y is less than or equal to 0 minus x. So I go to 0, put a point. Or you could have just said y is less than or equal to -x. Down 1/1. So to see if they ever intersect, did I do that right? Hold on, I feel like I forgot to write part of it down. Nope, 0. Okay. So down 1/1. So these are not ever going to intersect. Let's see, it is a solid line. I know my lines kind of look like they're going to intersect, but since they have the same slope, -x, -x, they're never going to intersect. They are parallel. And we're looking at shading. I forgot to do that. Sorry, y'all. I was just doing a pre-algebra problem. So the first equation, it's greater than that, so above. And this second one, it is less than, so below. So yeah, they're parallel and they are not overlapping anywhere, so no solution. Okay, on number 5. So on both of these, I'm going to have to rearrange them. So on this first one, I'm going to add 2x to the other side to move the whole thing. And I'm going to get y is less than, I'm going to go ahead and put my x first, but it doesn't matter, 2x plus 4. This one, same thing, I've got to subtract 2x to the other side. So y is greater than -2x plus 4, or 4 minus 2x. So I'm going to graph these. So this first one, I go to 4, put a point. My slope is 2x, so I go up 2/1, or if I go the other way, down 2 left 1. And it is a dotted line. And it says y is less than. I'm going to do the less than greater than part in just a second. So I'm going to go ahead and graph my other one. So I go to 4, put a point. My slope is -2, so down 2 over 1. Or up 2, left 1. This one was also dotted. If you noticed, they started at the same point. So it's very obvious where they intersect. Okay, so now let's look at our shading. So my first one, this one, y is less than that. So that would be shaded this way. This one, y is greater than this line, which would be shaded above. So then I'll go back, they intersect or overlap right here. Okay, now we're going to look at going backwards. We're going to be given a graph and we are going to write a system of linear inequalities. So from this, we're just writing two inequalities. So you just piece them together. There's different correct ways to do it. I just always start with, okay, well, we know we can always just go ahead and have y on the left side. I'll switch colors for that other one. Okay, so for one of my inequalities, I'll make this blue one will be this dotted line. So I know that that for sure does not have the or equal to. Okay, so I know that it's either greater than or less than. So go ahead and look. If this is that line, it is shaded below that line. So y is going to be less than. Okay, so then you look at your y-intercept. You always do slope last on these, it's easiest. It crosses the y-axis at 0. So that means my y-intercept is going to be plus or minus some number. This one will be plus 0, which means we actually don't even have to write it. Okay, then my slope, from here, it goes up 1, right 1. So my slope is positive 1, so positive 1x. So that inequality is just y is less than x. Okay, now this other one, the solid line one. I know it's got the or equal to sign, and if I look, it is shaded above that line. So I've got, I realized, we'll come back to that. So I know it's going to be greater than or equal to. I just realized it might trick y'all. Since it's a straight line, you know it's either missing an x or missing a y. And it crosses the y-axis at -2, so it's missing an x. I forgot to state that. I apologize. Because if it had been like this, there would never have been a y. It would have just been an x. So we have y, and it crosses the y-axis at -2. Okay, that's your y-intercept. But if you notice, it never goes up or down because slope always goes up or down first. And it never does that. So that means your slope is 0, which means there is no x. So these are your two inequalities that represent that graph. Okay, we're going to look at another one. So on this one, we've got our two inequalities. I'm going to go ahead and do the one that's straight up and down first, because those tend to trick people, whether it's straight up and down or straight across. So on this one, this line that's straight up and down, it's a solid line, so we know it has the or equal to, but on this time it's shaded to the left, so it's hard to know left or right if it's bigger or smaller. So you look at the axis. So it's at 3, and it's shaded this way, which means it's getting smaller than 3 on the x-axis. So that is going to be less than or equal to. Okay, now, it never crosses the y-axis, so there is no y-intercept. Okay, but it crosses the x-axis at 3, and it continually goes up. It never goes over. So that lets you know it is x is less than or equal to 3. For our other one, okay, it's a slant, so you know it has a y and an x. It's dotted, so we know it's either greater than or less than. And it's shaded above that line, so that means greater than. excuse me, it crosses the y-axis at -1. So whatever my slope is, my y-intercept is -1. So I've got something minus 1. So from that point, you have to find the next place where it actually intersects a point, which would be here. Looks like another one here. Okay, so from there to there, you count. That goes up 2 to the right 3. So that would be 2 over 3 x. Make sure your fraction can't be simplified. Sometimes if it was like 2 over 4, that actually means it also crossed here 1/2 because that simplifies. Okay, that one didn't, but I was just giving you an example of one that did. So these are my two inequalities for this. X is less than or equal to 3, and y is greater than 2/3 x minus 1. Okay, we are going to try, or I'm going to have you try some of these. I wish I could like go around it and click it like on a smartboard, but no. Okay, so using these two graphs, and you're going to want to pause the video so you can see them well, because when I do them on the board, I just had to draw them myself. So, or I have to draw them myself. So you're going to do 6 and 7. You are writing a system of linear inequalities to represent those graphs. Don't forget your dotted and solid lines. So pause the video, try those, and then I will go over them with you. Okay, so these last two problems were probably a little trickier because now we're working backwards. They give us the graph of the two inequalities, and we have to set up our inequalities. So I try my best to copy them. The pictures were better. But on number 6, right off the bat, you can tell that they're both dotted lines. So both of them do not have the or equal to line underneath that inequality sign. So it's either less than or greater than. So I'm going to start with the one up and down because that's easiest. When a line is straight up and down, that means for your slope, it's always going up. It never goes over for your y. So that would be x equals that number. So on this, I look, it's all positive 3. X equals 3, but it's not equals. It's got to be an inequality sign. And we know it's either less than 3 or greater than 3. So then you look at your shading. From this line, it's shaded to the left. If you look at your x values there, they're getting smaller. So x is less than 3. Okay, now looking at this one, being that it is slanted, we're going to have a y and an x. So I'm going to go ahead and put y. So if we notice, look at where your y-intercept is, where it crosses the y-axis. It crosses at positive 2, so I've got some other stuff, plus 2. Okay, from there, just count your slope. It goes down 1, right 1 each time. So that would be -1 or negative x. Okay, and now we look at shading. From that line, it is shaded below, so that means y is less than. There's your two inequalities that represent that graph. Oh, so you can see it a little better. Okay, on 7. These are both solid lines, so both of them have the or equal to line underneath. Okay, so just pick one of them. It doesn't matter. I'll start with this one. It crosses the y-axis at positive 1, so I have some other stuff, plus 1. From there to the next point, it goes down 1, right 2. And it continues that. So down 1, right 2 would be -1/2 x, because that's your slope. And then you look at this line, it is shaded above that line. So that would be greater than or equal to. Okay, now this one. It crosses the y-axis at -3. So I've got some other stuff, -3. It goes up 2 over 1. So that's a slope of 2 and your x. And then if you look at where this line is, it is shaded below that line. So y is less than or equal to. So that is your two inequalities that represent that graph.